Okay, in lesson 6, we're going to talk about slope-intercept form. Again, algebra 1 review. Slope-intercept form is y equals mx plus b, where m stands for the slope. Remember, that's the rise over the run. And b is the y-intercept. Important to note here, common mistake, the slope is attached to the x. If the slope is 3, well then it would say 3x. You wouldn't tell me the slope was 3x, you would just say it's 3. Okay, it is separate. So here, we're gonna write the equation of the graph in slope-intercept form. The y-intercept is just where the y is crossing, or sorry, the function is crossing the y-axis. So I'll highlight the y-axis in each of these. It's the one that goes up and down. And we're going to identify the y-intercept. Well, that's where it crosses. Right there. Okay. So that value is going to be the b for each one of these. Let's see. The b here is 1, 2, 3, 3 down. So -3. The b here is only down 2. And the b here is right in the middle. No up or no down, it's just right in the middle, so it's at 0. It's on the ground floor. Now let's talk about the slope. The slope is the rise over the run, so how far did we need to go up? 1, 2, 3, 4. And then we ran 2. Well, it's 4 over 2. We can reduce that. We need to. So my slope is actually 2. So if I put it together, y equals mx plus b. Y equals m is the slope. 2. X plus b. Well, when you add a negative, the negative wins. So it's going to stay negative. Over here, let's figure out what the slope was. I need to fall to get from the left to the right. So how far do we need to fall? Looks like 1, 2, 3, 4. And since we went down 4, that's going to be negative. And then we went over to the right. 1, 2, 3, 4, 5. -4 over 5. I cannot reduce that. So my formula is y equals m. -4 over 5. X plus b, well, another -2. And then here my slope. How much did I fall? I fell 1. And I'm gonna run 3 to the right. -1 over 3 is that slope. No reducing. Y equals -1 over 3x. And then plus 0 doesn't change anything. You can write it if you want to, but when you add 0 to stuff, it doesn't change it. Okay. So that's writing the equation. Now we're going to figure out how to graph each line. And I saw this the other day, and I really liked it. If you look at an equation in slope-intercept form like this one is, the y-intercept, you can say, this is where I start, this is where I go. So you're saying I'm going to start here. I'm going to start at -1. If I go down 1, that's where I'm going to start. I build everything off of this point. Where am I going to go now? 5 up, 1, 2, 3, 4, 5, and then 4 over. 1, 2, 3, 4. I got to do 3 dots though. The first one I place where I start, 1 up and 1 down if possible. So instead of, I can't continue to go 5 up and 4 over, it's going to go off screen. So I will go down 5, 1, 2, 3, 4, 5, and 4 this way. 1, 2, 3, 4. That works. All right. The slope here was 5 over 4. What's the slope here? Well, there's an invisible number in front of that x. It's an invisible 1. So my slope of this line is -1. and I'm gonna put that over top of a 1 because every number has a secret 1 underneath it, and then this way I can see rise over run a lot easier. Okay, remember this is where I'm gonna start, this is where I'm gonna go. So I'm gonna start at positive 6, all the way up to 6. 1, 2, 3, 4, 5, all the way up here. That's where I'm gonna start. This is where I start, this is where I go. I'm gonna go down 1, and 1 to the right. And I only really need 3, but this one's kind of easy. Down and over, down and over. We can do that maybe as far as we want to. And then the last one here, there's no y-intercept. I just have 2x. There's nothing else there. There's no, so if you want, you can write plus 0 if that makes you like understand where you're gonna go. So I'm gonna start here and I'm gonna go there. I'm gonna start at 0, right in the middle. And my slope is 2, but secretly it's 2 over 1. So I'm gonna rise 2 and go over 1. Over and over, and then I'm gonna go down in the other direction, okay? You only need a handful of these to figure out what the line looks like, but when it's easy to do slope, you can do the whole thing. Okay, so that's slope-intercept form. Now we're gonna talk about standard form. And standard form doesn't really do a lot for us. Standard form is ax plus by equals c. Standard form kind of sucks because we can't look at it and figure out what's the slope, what's the y-intercept. It gives us no information for graphing. So we're going to need to be able to convert between standard form and slope-intercept form. Don't be thrown by the a, b, and c. A, b, and c just stand for constants. They just stand for numbers. They could be any number in the world. Number A is different from number B. Okay, what is important is the x and the y. So here, I'm trying to get the y all alone because that's how we get it into slope-intercept form. In order to get the y all alone, the x that is with the y needs to move. So it looks like it's a positive x. To move something, I do the opposite of what it is. Now my y is all alone. I'm gonna write that as 6 minus x. And that's a true statement. Y does equal 6 minus x. If I subtract that, that's fair. Everything works. But in slope-intercept form, the x comes before, right? It's y equals mx plus b. So I'm gonna take these two things and I'm gonna change them around. Negative x, I gotta keep the sign with it. And then this 6 is positive. Now if I wanted, I could look at this and say, okay, I have a y-intercept of positive 6 and my slope is negative 1 over 1. And that's easier for me to see than what's the slope and what's the y-intercept here. Same thing, I want to get this y all alone, so that 5x needs to move. This time I'm going to write the x first because I know I'm going to swap it anyway. So I'm going to just put this first when I write down on this side. And then I'm not quite done getting the y all alone. Like it's all alone on the left, but there's that 2 in front of it. And then 2 over 2 becomes 1. Okay. There, my slope is negative 5 over 2. Keep it like that. Keep it as a fraction. We want it as a fraction anyway. Slope is a fraction. And then this one, I have to subtract, okay, negative 4y, negative 2x plus 28. Okay, so far same thing, I moved the x, it's happened every time. Now just like this one, I'm gonna need to divide by whatever is in front. Just remember to keep the sign with it too as you divide. Okay. 2 over 4 will reduce to a 1 over 2. And a negative divided by a negative makes a positive, so it's going to be positive 1 over 2. 4 and 28 is going to go in there 7 times, and a positive divided by a negative is a negative. So my y-intercept there is -7, and my slope is 1/2. I don't think we need to do any more of those. I think you can understand where we're going with that. Now we're going to jump down to these. We're going to solve, and then we're going to graph them. So it's the same work that we just did, but now we're going to have that extra step of graphing it. So with number 13, I need to get the y all alone, and it has that x hanging out with it. Subtract the x.
No, we're talking about like brutality for no reason.
Okay.
Just like
Now, I'm
if
going
you,
to
like,
divide by -2. And I'm going to divide everything by -2. Y equals negative divided by negative is a positive, and there's a secret 1 in front of this x. 1 divided by 2. And then 2 goes into that 4 times, and a positive divided by a negative is a negative. So, I'm going to graph this. This is where I start. This is where I go. I'm going to start at -4. And my slope is 1/2. That's going to be rising 1, running 2. Up 1, over 2. Up 1, over 2. Up 1, over 2. And if I wanted, I could go the other way. Down, over 2, down 1, over 2. I could draw it like that. Okay. We're going to do this one over here the exact same way. Move the x. 5y equals -3x plus 5. And now we're going to divide by that 5, but we're going to divide everything by 5. Y equals -3/5, because negative and positive make a negative. And an x goes with that. And 5 goes into 5 1 time. This is where I start, this is where I go. We're going to start up at +1. My slope here is a -3/5, so that means I'm going to fall 3. 1, 2, 3, and then go 1, 2, 3, 4, 5 over here. I'm going to go the other way now. I'm going to rise 3. 1, 2, 3. 1, 2, 3, 4, 5. Okay, good enough. All right. Okay, here's a vertical line. Vertical line is written in the form x equals a, where a is the intercept. Basically, if you have a line that's going straight up and down, just like this one, this line is going up and down. It is defined as your x equals whatever value on the x-axis this is. So, right here, I have the x-axis. Okay. And if this is the origin, this is the middle, this is 0, 0, think about this as a number line. If I go to the right, it's going to be 1, 2, 3, 4, 5 forever. But from the middle to the left of a number line are your negative numbers. -1, -2, -3, -4, so on, right? Well, where this crosses on your number line is at -1. So that's why your x equals -1. And we know that a straight up and down line has an undefined slope. When you have a horizontal line, a line that's laying perfectly flat, you have a y equal line, and your equation is equal to where it crosses on the y-axis. So think about this like an elevator, okay? Here's the ground floor, and as you go more towards the basement, you're gonna go into the -1, -2, -3. But if you're going up floors. Well, this crosses at the 1, 2, 3, third floor. So that's why this is y equals 3. And this doesn't have a slope, it's perfectly flat. If you're walking this, it's not a workout. No slope like that. So we're gonna graph each line. And this is easy, this is quick. We have a y equals, so we know the line is gonna be laying flat. And it's gonna be laying flat on this floor, the fourth one. 1, 2, 3, 4. Here we have an X line. X is up and down, and it's on that number line. So the number line of -2, 1, 2, over here. The last one here, y equals 0. Well, this is a horizontal because it's a y line, and it's going to be on that floor. Looks to me like that's 0. No up, no down, no. It's on the ground floor. Determine whether these equations are parallel, perpendicular, or neither. So we're going to need to take these two equations, put them in slope-intercept form, and then just look at the slope. Remember, a perpendicular slope is negative, or the sign changed and it flips, and parallel slopes are the exact same. So let's see here. This is already both in y equals. The slope here is attached to the x. Your slope is 5. Right here, your slope, sorry, not y. Your slope is 5. Okay. When you have the exact same slope, they're parallel. Over here, they're already in y equals. Y is all alone. That's already set up. Your slope here is the thing attached to the x. And over here, same deal. It's the thing attached to the x. They're not the same. They're not exactly the same, so they're not parallel. But one's negative, one's positive, a 3 over a 2 and a 2 over a 3. It looks like, yeah, I have that sign change and that flip upside down. So this is perpendicular. All right, these ones are going to take a little bit of work. I want to get the y all alone. Subtract the x. And then I need to divide by whatever's in front of the y. Y equals negative 1 over 2x plus 1. Okay. So that's the equation of the line. The slope is whatever's attached to the x. Okay. Let's see what this one looks like when we're done with it. Move the x. Negative 3y equals negative 6x plus 21. Divide by negative 3. Y equals negative, divide by negative makes positive 2x minus 7. Okay, well I gotta compare the slope here. The slope is whatever is attached to the x. It's a 2. But underneath every whole number is a secret invisible 1. So let's compare. 1 over 2, 2 over 1. Okay, so I have that flip. And one's negative, one's positive. This is perfect. One more. 21, get the y all alone. Negative y equals negative x plus 9. Okay, so here's a trick. Here's an algebra trick. You don't want negative y, you want positive y. So no big deal. Change it to be positive. But the algebra rule says what you do to one thing, you gotta be fair. You gotta do it to everything else. So if I change this sign, that's fine. I just gotta change everything else's sign. So now my slope is what's in front of the x, and there's an invisible 1 there. So I'm gonna put it as 1 over 1, because again, a lot of invisible math here happening. The 1 is invisible, and then that 1 is an invisible 1 underneath it. Here, it's already in y equals mx plus b form. The y is all alone. My slope is whatever's in front of there, 1. Remember, invisible 1. I see that they are exactly the same. Okay. And I bet if we kept going, we'd find an example of one that was not the same or perpendicular. An example of that might be, I don't know. Let's say I did all the work here, and I got down, and my slope was 1/3. Okay, let's just say that's what happened. And I do all the work, and I get down here, and my slope here is -1/3. Okay. Well, they're not exactly the same, so they're not parallel. One's positive, one's negative. The number doesn't matter in that case. But one's positive, one's negative. It's not perpendicular either because I need that flip, and I don't have that here. So this is neither. That maybe is an example of what one might look like, but I'm not going to do all these. If you want more practice, you're welcome to. We are going to talk about these though. If you have a Y line, think about what that means. A Y line is one that looks like this. And if you have an X line, think about that. That means that you have a line that looks like this. So on a coordinate grid, if we were to graph that, you might have your Y line looking like this. And you might have your X line looking like that. Always and forever, there's gonna be a 90-degree angle here. So these will always be perpendicular. When you have an X line and a Y line, always perpendicular. Here, you have two X lines, which means that you have two up and down lines. And we can even graph what this will look like. This one's way over here at 9, and this one's at -5, so it's about there. Well, those lines are going straight up and down forever. These are never going to touch. They have the exact same slope, so they are parallel. Whenever you have two of the same type, whether it's two X's or two Y's, they're going to be parallel. Okay. All right. And these ones. Okay. We do have to do these ones. Looks a little obnoxious, but we can pick this apart and make it a little bit easier. Which line is parallel to the line shown below? So two things we need to know. One, parallel means same slope. That's the first thing we need to know. The second thing is, well, what's the equation of this line in the first place? Let's see. It has a slope of 1, 2, 3, 4. I'm gonna rise 4. I'm gonna run 1, 2, 3. Okay. And actually, I don't need to know the whole equation because I only care about the slope. So I'm gonna forget about the y-intercept. I'm gonna see which one of these down here has the exact same slope as this. Okay. Now, let's be smart, because we could transform all 4 of these the same way. Try to get y all alone, but that would take a lot of time. Let's cut our work in half. Think about what this looks like. It's a 4 divided by a 3. And what have we always done? It was move the x, mostly by subtracting, and then divide by whatever is touching the y. That's what we always did. If you go back, that's always what we did. Move the x, divide by the y. A fraction is really a division problem. This 4 is being divided by 3. So if I'm going to divide by the y, and here I'm dividing by 3, let's find the y's that have 3's. Those ones are not it. Okay. These ones would say, move this and divide by 4. We want to divide by a 3. So now, we only have to transform one of these, not both, because if we transform one and it matches, that's great, the answer is C. But if we transform this and it doesn't match, we know by default the answer is D. So instead of doing all 4, we only have to transform 1. All right. Let's see, I'm gonna take this one. 4x plus 3y equals -6. I'm gonna subtract the x over. Okay, and I'm gonna divide by that 3. Y equals -4 over 3x minus 2. Okay. The slope of this line is -4 over 3. I wanted +4 over 3. So it's not C. which means by default, it has to be D. Okay, and I bet if you want, you can transform that one, and you'll see that that works. We're gonna do the same series of shortcuts here. We're gonna figure out what slope this has in the first place. The slope that we have is, I'm gonna fall 1, 2, 3, 4, 5. Since I fell 1, it's negative, and since I ran 5 to the right, that's gonna be positive. Okay, so that's the slope of that line. But right here, it says it wants a perpendicular. So I need to flip and change sign. So instead of negative 1 over 5, we want a positive 5 over 1. That's the slope that we want. Okay. So let's go back and see if we can cross off some answers. The 5 is being divided by 1. And remember, we always want to divide by whatever is in front of the y. So we need to find the y's that have the 1s, because those are the answers that we want. These ones right here, they have the 1s in front. Let's take A and let's transform it. This one right here, 5x minus y equals 3. Subtract x from both sides. Negative y equals negative 5x plus 3. And then I have a negative y. I don't want that. Remember, I can change a sign. As long as I change everything else's sign too. Negative 5 becomes positive 5. That becomes negative 3. Okay. So, perpendicular to that, looks like, yep, that matches. That will work for me, right? Because there's an invisible 5 underneath there. The answer here was A.